Chapter 5 Non-return flow and pressure valve combination. Here are some examples. Non-return valve, pressure valve, as well as the combination valves. First, we have to talk about the non-return valves. Non-return valves are devices which preferentially stop the flow in one direction and permit the flow in the opposite direction. The pressure on the downstream side acts against the restrictive components, thereby assisting the sealing effect of the valve. So, let's check the example. The non-return valve devices are installed in the system that needs to control its flow specifically to allow its flow in only one direction, in avoiding backflow, which is the unwanted airflow in the reverse direction side of the tube. So this kind of valve prevents any contamination of the dispersion of harmful air in case of reverse fluid circulation. Check valves. Check valves are usually formed by a shutter, a spring, and a gasket, and the operating principle is very simple. As soon as the fluid pumps into the pipe and reaches the value that overcomes the force of the spring, the shutter will open and it would let the fluid to free flow. As the higher the fluid pressure, as the bigger shutter opening will be. The pressure value falls below the value of the counteracts the force of the spring. The shutter closes, preventing any backflow. Next one is the junction elements. Junction elements that fitted a three-way junction which have the non-return characteristics and direct movement of signal air. These are the processing elements whereby two signals are processed internally and resulting signals is output at port 2, and these are the following examples. End function. The dual pressure valve requires two signals to produce an output. OR function, the shutter requires at least one input signal to produce an output. Dual pressure valve end function operation. Logic end function. In the case of pressure differences between the input signals, the signals with lower pressure reaches the output. While if we talk in the case of time differences between the input signals, the signal arriving last reaches the output. If we can see in the truth table of the two dual pressure valve, we can see that X and Y is the input and Z is the output. Consider that 1 is the compressed air is available while 0 compressed air is not available. So X and Y is the input and Z is the output. As we can see in the truth table, if we input X and Y as 0, we have the output Z 0. If we have the X and Y input of 1, we have the output of Z equals to 1. So it means to say that end function gives us output compressed air signal if all inputs have compressed air signals applied at the same time.
For the continuation, other types of non-return valve are shuttle valve, quick exhaust valve, and shut-off valve, to be presented by Albert Biscoccio. First, shuttle valve logic or function. This non-element has two inlet, port 1 and port 1-3, and one outlet, port 2. If compressed air is applied to the first inlet, port 1, the valve seals the opposing inlet, port 1-3, and air flows from port 1 to port 2. Port 1 is closed. If air passes from port 1-3 to port 2, a signal is generated to the outlet. When the airflow is reversed, for example, a cylinder or valve is exhausted, the seat remains in its previously assumed position because of the condition. This valve is also called an OR element. If a cylinder or control bulb is to be actuated from two or more positions, one or more shuttle bulb should be used. Here are video animation of how a shuttle bulb operates. As it's seen in the animation, the compressed air passes through the inlet of port 1 and out to the port 2. The piston lock pushes by the air pressure that covers inlet port 1-3. When the compressed air enters the inlet port 1-3, the port 1 is closed and out to output port 2. Shuttle bulb can be create additional logic or conditions. For example, as shown below, if any of three push buttons are operated, the cylinder is to extend. Next is quick exhaust bulb. Quick exhaust bulb used to increase the piston speed of cylinder. This enables lengthy return times to be avoided, particularly with single-acting cylinder. The principle of the operation is allow the cylinder to retract at its maximum speed by reducing the resistance to flow of the exhausting air during motion of the cylinder. To reduce resistance, the air is expelled to atmosphere close to the cylinder by a large orifice opening. The bulb has a closable supply connection port 1, a closable exhaust port 3, and an outlet port 2. If pressure is applied at port 1, then the sealing disc covered the exhaust 3, whereby the compressed air passes from port 1 to port 2. If pressure is no longer applied at 1, then the air from port 2 moves the sealing disc against port 1 and close this, whereby the exhaust air immediately vents to atmosphere. There is no need for the air to pass through a long and possibly restricted path to the directional control bulb via ducting lines. It is advantageous to mount the quick exhaust bulb directly on the cylinder or as near to it as possible. Last, shut-off bulb. Shut-off bulb are non-adjustable which release off shut-off flow in both directions. Typical examples are the stopcock and ball cap. The air pressure enters port B and out to port A, and vice versa. A shut-off knob are used to cut the flow of the compressed air.
Flow control bulbs influence the volumetric flow of the compressed air in both directions. Throttle bulb, normally adjustable and the setting can be locked in position. At ito ay isang flow control bulb. Throttle bulb are used for speed control of cylinders. Care must be taken that the throttle bulb does not close fully, cutting off air from the system. Characteristics of flow control bulb to construction principle. Throttle bulb, the length of throttling section is greater than its diameter. Diaphragm bulb, the length of the throttling section is less than its diameter. One-way flow control bulb. The airflow is throttled in one direction only. A check valve blocks the flow of the air in the bypass leg, and the air can flow only through the regulated cross-section. In the opposite direction, the air can flow freely through the open check valve. These valves are used for speed regulation of actuators and, if possible, should be mounted directly on the cylinder. Two types of throttling circuit for double-acting cylinder. Supply air throttling, exhaust air throttling. For supply air throttling, one-way flow control valves are installed so that the air entering the cylinder is throttled. The exhaust air can escape freely to the check valve of the throttle valve on the outlet side of the cylinder. The slightest fluctuations in the load in the piston rod, such as occur for example when passing a limit switch, lead to a very large irregularities in the feed speed. A load in the direction of movement of the cylinder accelerates the cylinder beyond the set value. Therefore, supply air throttling can be used for single-acting and small-volume cylinders.
Exhaust air throttling. With exhaust air throttling, the supply air flows freely to the cylinder and the exhaust air is throttled. In this case, the piston is loaded between two cushions of air. The first cushion effect is the supply pressure to the cylinder, and the second cushion is the exhausting air being restricted at one-way flow control valve orifice. Arranging throttle relief valves in this way contributes substantially to the improvement of feed behavior. Exhaust air throttling should be used for double-acting cylinders. In the case of miniature cylinders, supply and exhaust air flow control is to be selected because of the reduced air quantity. Exhaust With exhaust air throttling, supply air flows freely to the cylinder and the exhaust air from the cylinder is throttled. This creates a state where the piston is loaded between two cushions of air. On one side, the supply pressure, and on the other side, the exhaust air being restricted by the throttle. The exhaust air has to pass the throttling office since the check valve closes the bypass. Exhaust air throttling improves the motion behavior of cylinders at low speeds. It is the only one recommended way of throttling for double-acting cylinders. Mechanically adjustable one-way flow control valve. Mechanically adjustable one-way flow control valves. The speed of the cylinder can be changed by an adjusting screw by means of an irregular shaped follower, which actuates the roller lever of the mechanically adjustable one-way flow control valve. The throttle cross-section is correspondingly changed. Flow control or one-way flow control valves regulate the piston speed of pneumatic drives during advance and return strokes. This is done through suitable restriction of the flow rate of compressed air in exhaust air or supply air direction. The flow control function creates an adjustable annular gap inside the valve. In mechanical adjustable one-way control valve, the speed can be changed by an adjusting screw.
I'm here to discuss about the pneumatic section B, chapter 5.3. Pressure valves. Pressure control valves are elements which predominantly influence the pressure or are controlled by the magnitude of the pressure. It is divided into three groups. The first one is the pressure regulating valve, the second is the pressure limiting valve, and the last is the pressure sequence valve. The pressure regulating valve. The pressure regulating valve is dealt with under the section B 2.6 or service unit. The role of this unit is to maintain constant pressure even with fluctuating supply. The input pressure must be greater than the required output pressure. Here is the sample circuit and schematic diagram of the pressure regulating valve. The next is the pressure limiting valve. Pressure limiting valves are mainly used as safety valves or pressure relief valves. They prevent the maximum permissible pressure in a system from being exceeded. If the maximum pressure has been reached at the valve inlet, the valve outlet is open and the excess air pressure exhausts to the atmosphere. The valve remains open until it is closed by the built-in spring after reaching the preset system pressure. Next one is the pressure sequence valve. The principle on which this valve acts is the same as the pressure limiting valve. If the pressure exceeds the set on the spring, the valve opens. The flow from 1 to 2 is closed. Outlet 2 is open only if the preset pressure has built up into pilot 12. The pilot spool opens the passage 1 to 2. Pressure sequence valves are installed in pneumatic controls where a specific pressure is required for a switching operation. It is pressure dependent controls. Here is the circuit diagram with pressure sequence valve.
What's up guys, I'm Alexander in B2 review of BSEE 4GJ and I'm going to further discuss to you the different functions of combinational valves, kung ano nga bang combinational valves and why is it important sa ating pneumatic system. So if you want to gather more information, stay tuned and listen to my explanation. Components of different control groups can be combined into a body of one unit with the features, characters, and construction of combination of valves. So in other terms, search in Wikipedia, combinational air valves perform the functions of an air vacuum valve, exhaust large quantities or an air startup admits air on the shutdown. So, ang ating combinational air valve daw ang nagtatransport or nagtatransmit ng air sa different components. And air release valves releases air continuously during operation to maintain system efficiency and prevent pipeline surges. For the time delay valves, it is for the delay of the signals. Ang time delay valve natin ang bahala na magde-delay sa bawat signals natin. So, it is used to delay the output signal. The time delay valve is actuated by a pneumatic signal through the tank after preset time delay has elapsed. The return to the normal position via return spring when the signal is transmitted or terminated. Air control blocks, it is for the execution of individual and oscillating movements using the double-acting cylinders. In other term, ang ating air control valve daw ang ating building blocks of pneumatic control. So, kung wala ang ating air control blocks, hindi magpo-function ng ating iba't ibang components. 5-4-way valve, it is for the stopping of the double-acting cylinders in any position. So, ang ating 5-4-way valve daw replaces up to 4 2-way valves and it lessen the time and the effort required for the installation. Air-operated airway valve, it is for the control if feed units. So next is the pulse generator. It is for the execution of rapid cylinder movements. So sabi dito, ang ating pulse generator daw is either an electronic circuit or a piece of electronic test equipment used to generate rectangular pulses. So pulse generator are primarily for working with digital circuits, related functions, generators, and are used primarily for analog circuits. So bawat input natin ang nagiging equal nun ang ating rectangular pulses or the shapes. As the input is greater, the shapes or the rectangular pulses is also greater or longer. So the vacuum generator with ejector for pick and place applications. So vacuum generators daw ay we need it for handling tasks such as the ejector, pumps, and etc. Vacuum generators come in an extensive array of types, sizes, design, and efficiency to suit widely. Stepper modules for sequential control task. So, sabi dito, ang ating stepper module daw ay specifically designed to drive stepper motors, which are capable of continuous rotation and precise position control, even without a feedback system. Our stepper modules offer adjustable current control and multiple step resolutions, and they feature built-in translators that allow the stepper motor to be controlled with the simple step and direction inputs. These modules are basically and generally carrier boards of the variety of stepper motor driver ICs that offer low-level interfaces like input for the directly initiating each step. An external microcontroller is typically required for generating these low-level signals. Next is the command memory modules for the startup with signal input conditions. So itong dalawang to ay mahalaga din sa ating pneumatic system. So the time delay valve is combined with 3 two-way valve, the flow control valve, and the air reservoir. So the 3 two-way valve can be a valve with normal position open or closed. So, ibig sabihin dito, ang ating 3 two-way valve is either open or closed, and the delay time is generally 0 to 30 seconds for both types of valves. That is how to distinguish our time delay valve. So here in our figure 5.20, the time delay valve is normally closed. As we can see, the different labels such as the 12, 3, 2, 1, lahat to nagsisimbolize ng ating time delay valve is normally closed. So, bawat functions yan ay mahalaga, bawat purpose niyan, bawat parts is mahalaga. By using additional reservoir, by time can be extended, an accurate switch over time is assured if the air is clean and the pressure relatively constant. The operation principle. The following operational principle applies for time delay. For time delay valve with the 3 two-way valve in normally closed position. Ito yung mga nagde-describe ng 3 two-way position or normally closed position. First is the compressed air supplied to the valve at connection 1. The control air flows into the valve at 12 through a one-way flow control valve, and depending on the setting and the throttling screw, and a greater or lesser amount of air flows per unit of time into air reservoir. When necessary control pressure has built up the air reservoir, the pilot spool of the 3 two-way valve is moved downwards, pababa. This blocks the passage from 2 to 3. So, binablock daw niya yung passage from 2 to 3. The value disc is lifted from its seat, and thus the air can flow from 1 to 2. The time required for the pressure to build up in the air reservoir is equal to the control time delay of the valve. If the time delay valve is to switch to its initial position, the pilot line 12 must be exhausted. The air flows from the airflows of the air reservoir at the atmosphere to the bypass at the one flow control valve and then to exhaust line. The valve spring returns to the pilot spool and the valve disc seat to their initial positions, working line 2 exhaust to 3 and 1 is blocked. So here in our figure 5.21, the time delay valve is normally open. As you can see, the units or the components 10, 3, 2, 1, lahat yan nagsisimbolize, and the diagram here symbolizes that the time delay valve is normally open. The normally open time delay valves includes a 3 two-way valve which is open, obviously. Initially, the output 2 is active. Pag the open ay active ang 2. When the valve is switched by 10, the output 2 is exhausted to 3 and 1 is closed. The result is that the output signal is turned to after a time delay. The time delay corresponds to the pressure buildup in the reservoir again. If the air at the port 10 is removed, then the 3 two-way valve assumes the normal position. The circuit below utilizes two time delay valves. One normally closed valve which is the 1V2 and the other is the normally open valve which is the 1V1. Upon operation of the start button 1S1, the signal generated passes through the valve 1V1 and initiates the movement of the cylinder extension 1A via 14 port of the control element 1V3. The time delay valve 1V1 has a short time delay of control element 1V3. The time delay valve 1V1 has a short time delay set of 0.5 seconds. This is long enough to initiate the start signal, but then the 14 signal is cancelled by 10 pilot signal of the time delay valve. The cylinder operates limit valve 1S2. The time delay valve 1V1 receives a pilot signal which after the preset time opens the valve. This supplies the 12 signal which reverses the valve and reacts to the cylinder. A new cycle can only be started via start button and renewed actuation of the valve 1S1. So as we can see here in the figure 5.22, the circuit diagram with time delay valve. So each components is important. Makita natin na lahat yan ay nagsisimbolize ng time delay valve natin. The following illustrations show the time behavior of the circuit with time delay valves. So here in our figure 5.23, the time response of the circuits with time delay valves. Lahat yan ng mga circuits natin nagpo-function sa ating clock pulses. Each functions corresponds to clock pulses. Like the time response with delay on, makita natin yan ang clock pulse niya. And the second is the time response with delay off. This is the circuit, and this one is the clock pulse. The third one is the signal shortening with signal switch off. Yan ang ating circuit, and this one is our clock pulse. And the last one is the signal lengthening. This one is the circuit, and this one is the clock pulse. So makita natin na lahat ng diagram ay nagko-compromise or nag-e-effect ng ating clock pulses. That's it. Thank you for listening to my report. Maraming salamat po. God bless and stay safe.